4 brave developers, 5 intense hours, and 1 mission to build an AI agent you can truly bank on.
I think we're going to go with the thing that we all lit up for when I saw it on the screen.
The clock is ticking.
The pressure is on, and your time starts now.
Hey guys, I was just invited by Google in San Francisco to imagine the future of banking with agents. I was part of the Agent Bake-Off Challenge where I was paired with a Google engineer to think about how we can use the Google Agent Development Kit, the A2A protocol, and the different Gemini models to really push the boundaries and the limits of what's possible today. Under 5 hours in this challenge, we managed to build an agent that runs simulations, that can create graphs, and that can set up budgets for travel plans. And in this video, I want to deep dive into what we built, how you can build it as well. And if you want to watch the full Bake-Off episode, I'm going to be sharing the link to the Google's video below. Here's the plan. There are 2 major things we're going to do. First, I'm going to show you how we can set up the agent that will help us create financial simulations, create charts, and connect to other agents via the agent-to-agent protocol, also known as the A2A protocol. And then I'm going to show you how we can connect this agent to a nice front end so that we can build a full stack application which will let users interact with our agent. All right, so let's go. Right, so before we dive into the code, I just want to show you quickly how the app works. So basically, we are just providing it a user ID, and I'm going to say, what's my net worth? And now it's essentially what it's going to do is connect to the remote agent that has access to all this financial transaction. And basically, this has been provided to us by Google, where they're just storing like just some made up data. And now you're going to see that the agent is going to fetch this information. And as you can see here, it's showing us exactly our net worth. So it's answering the question. And then what it has also, it's sharing the different actions that it took. So it connected to the remote agent called also the simple banking agent. And then it performed like calculation to help us identify our net worth. And that's pretty much how this works. Help me display this on the chart. And now what you're going to see is the agent is basically going to create a graph to help us visualize this assets against the liabilities. So you can see assets 83,000, liabilities 62, and net worth 21. So in the pie chart. So obviously you can see that those are just bars, but you can also generate, you can see 401k, savings, and checking. So you can see it called the HTML. So the graph generator, the graph generating agent. And finally, if I invest, let's see. So now basically what it's supposed to do is call the calculator agent to simulate and understand how much we will have earned. And then it's going to pass all this information, so the time series, to the graph generating agent to help us display it on a line chart. Let's see if it works. Okay, so I use this information, and now it basically showed us the incremental savings. So we are basically, and this is basically displaying the data that is being displayed. So year 1 to year 10, how much we will have earned in total by investing at 10%. And you can see that it starts at this amount over 10 years, and it's showing us a graph chart. Perfect. So now I'm going to dive into the code and show you exactly how it works under the hood. And as always, I like to start with a little diagram. So basically, we have this root agent that acts as the point of contact between the user and the front end in our case, and the backend. And so within this agent, we have a handler agent who will in turn have different capabilities. And so in our case, we have an agent that has access to financial transactions via the A2A protocol, and I will show you how this is set up. Then we have another agent that can run calculations and simulations. And then finally, we have an agent that has access to a set of tools to generate those graphs. And then step 2, we're basically going to add a UI layer on top of our agent. So as you can see here, basically the backend is going to respond, and we're going to hit the API endpoint of the backend directly from our Next.js application, which will then be rendered in a component that we will then display on our page. And then basically what we're going to have is a user that will interact and send a message, and then the agent is going to go through each of the steps and then stream all the responses back to the user. The beauty of this agent is that not only it can generate graphs, but also it's going to stream its response, thereby giving some visibility to the user into how the agent is behaving and performing to build up trust with the user. Great. So now I'm just going to dive into the code. If you are not familiar with the Google Agent Development Kit, I will be showing more links to more in-depth videos on how you can get started. But otherwise, I will jump into the code. All right. So now just a little bit more info about the agents and their core functionalities. So like I said, this was a challenge where we're really trying to push the boundaries of what we can do with the Agent Development Kit, play around with the different functionalities of the Google AI tech stack. So basically here we have an agent that connects to a remote agent that has access to the financial transactions of different users. I will show you how this looks. That we're going to connect to via the A2A protocol. Then we have the calculator agent. This is where we're basically showcasing how we can use code execution. It's a built-in tool that Google offers as part of the Agent Development Kit to run calculations. So I will show you this as well. And then finally, we have an agent with a more traditional suite of tools that it can call depending on what we are asking it to do. And finally, what we have is this thing called callbacks, after agent callbacks, meaning that every time that this graph agent runs, it's actually going to save its results, in this case, the graphs, so that we can display them on the front end. So I will show you each of these capabilities that we have built and how you can use that as well. All right, so now I am in Cursor. So in Cursor, we have this root agent. So if you are familiar with Google's agent development kit, you probably know that you have the root agent that you need to name root agent in the root folder. So as you can see here, banking agent is part of the exercise. And as part of this root agent, we have this handling agent that has the different capabilities, and it also has access to this remote agent. So this remote agent, I think this is the first thing that I want to show you. What we're doing is we're connecting to a remote agent that has access to financial transactions. So this has been supplied to us by Google. But what I really want to show you is there are more in-depth tutorials about how you can interact with the A2A protocol. The A2A protocol is just a way for you to deploy your agent, and then you can create some sort of a business card where you can define the different skills for which your agent can help. And in this case, we have a remote agent that can help us answer questions such as what are my current debts, what's my investment portfolio, what is my current net worth, and so on and so forth. And you can see also that it has different input modes and output modes. So in this case, it's going to return us text, and then we're going to basically be handling the information within our core agent, right? So it's just a simple class. And then what we are doing here is, if you go to the handler agent here, what you have is we are wrapping this remote agent as a tool, meaning that every time that the handling agent needs to access this information and use it with other tools within a specific task, it can call it. So in our case, what I will show you is if we are to ask the remote agent, what is my current financial situation, it's going to extract the assets that I own, the liabilities that I have, and then if I ask it like a follow-up question on, simulate my future net worth if I invest X amount for 10 years, then it's going to use that context and call the calculator agent to then help us visualize how our net worth will evolve over time. And same logic applies to whenever we want to generate graphs. So those are just like different prompts explaining the different capabilities and how to use specific agents and when. So that's what I wanted to show you. Then if I go back to what I was saying, so this was about the remote A2A agent. Now if I go over to the calculator agent, it's very simple. What we have is this built-in code executor. So basically here we're just providing this coding capability. So this is also one of the built-in tools that the Google's agent development kit framework offers. So as you can see here, we have it there built in the code executor. We also have like the Google search tool, which we eventually used also to find information online about ticket prices as part of the concierge section of our agent. It's out of scope. I'm not going to show it, but it's very similar. And then this graph agent is this one. This one is a little bit trickier. This agent, we're just providing it like very specific guidelines on how to absorb the information from the agent. The way this agent works is we pass it with a bunch of information, and then we want it to generate different types of charts. So it can generate pie charts for us, bar charts, line charts, and we are giving it a direct chart generator and like a set of tools that it can call in order to generate those graphs, and also this capability to look up matplotlib docs. So if I go over our tools, this is just using here calling the grounding tool from Google, where saying, okay, you are only allowed to look up in this doc URL the information that we're looking for. So whenever our agent doesn't really know how to create a specific graph, it can look up and create and call this tool. And finally, what we have is also this direct chart generator, which we're going to pass like some chart data. So you can see here we're explaining exactly when it should be called in the description of the tool. And then basically it's just a set of run functions that get called every time we call the class. So in this case, this tool. And then in this tool, we are providing it with. So that's pretty much how the HTML agent runs. So here, and then what I'm going to show you is every time the agent calls these tools to generate the graphs, it's going to call this after agent callback, which is this function that will save the image that has been generated and save it in artifacts, which are a way for us within Google's agent development kit to save information and state whenever we interact. So you can save pretty much what you want. In this case, you can see that we're saving coding results. So that means that every time we are generating this, like some simulation data, we can actually save this data and call it later on in different sessions if the user has, wants to ask the same question on and on again. Great. So I think this was a little bit heavy. So now I'm just going to go to the ADK web server to show you how all of it is set up. So up. So now I'm just going over the banking agent and I'm going to show you how this works. I say, hi, what's my net worth? You can see now it's calling this remote agent because it knows that basically we have this information as we saw in the business card from this remote agent. So it's going to return the information. So now it's still calling this remote agent. You can see here and you can see that my net worth now is 21,000. So it actually calculated all my assets, all my liabilities, and then it just gave me the difference. And now actually the agent went a bit ahead of itself, but it did actually show us the assets, the liabilities, and the differential. So it helps us display the net worth directly on the graph. So as you can see here, it already has this multi-model capability. Second thing that I want to show you is if you want to, let's say, simulate the output. I want to say if I invest 10K today and it returns 10% year on year, what will be my net worth in 10 years? So now basically the agent is going to know that we're trying to simulate future earnings. So now it's using the calculator. You can see it's understood the kind of calculation it has to do, and as you know, with LLMs they are generally a bit brittle when it comes to calculations, but by having this built-in agent, it knows exactly how to pass the parameters and structure it. So now it actually shows us exactly how much we would have earned. So if we had invested at 10% 10,000, we would basically increase our net worth by 5,937 because we started off as with 21. And what's quite interesting is that you can see that it's showing us exactly how this would have been projected directly on the graph. So as you can imagine, if you have an agent, a bot that you're interacting with about your financial situation, it could display graphs like this dynamically. So now I'm going to move to the front end to show you exactly how we can display that. Okay, great. So now that we know how it works under the hood, what I want to show you is basically how you can connect this to your front end. And the best way to do that is just to show you how the API is set up to connect to an ADK agent. So what's interesting is that there is the fast API that you can add to local 800 when you run your backend. And what's interesting is basically to run your agent, you have two different options. You can either run it with the run, meaning that you are only returning the final output, or you can also stream with basically the server side events, meaning that this will allow us to stream the output and over time, thereby providing us with better feedback as we are interacting with the agent. So here, what you can see is we have three different parameters that we need to pass to kickstart the agent. The first one is the app name, then the user ID, and then the session ID. And so in our case, basically, we have the banking agent, which is our app name. The user ID is just being passed. So in our case, we are using user 001, and it defaults to 001, and therefore everything that we've been seeing has been for like a specific user in the database. And then we can either create a new session, save the session, and so on. But in our case, because we're not saving the information anywhere, we are essentially creating a new session, and then we are running with that session until we stop, basically. And then finally, what we are doing is we are passing message in parts to the agent. And finally, what you have is this example of a response where you have the content parts, and then we're basically going to be streaming this information over time. And this is just like an example of how you can handle the response from the agent. I'm going to dive into more details, but as you can imagine, that all of this response allows us to be super specific in how we want to handle the agent response. But that's pretty much it in terms of SSE. So the only difference is that here we're streaming the responses over time. whereas with the run agent, we are just getting the final response in once. So basically in our front end, so now I'm just going to show you how we are setting up our front end. All right, so here is how the front end is set up. Basically, whenever the user sends a message, it goes through the page, then it goes through the hook, which will basically structure and orchestrate how all the messages will be sent out as parts to the agent. And via the API route, we're going to structure all the key parameters that we need to interact with the agent. So the app name, the session ID, and pass the user ID. And then eventually, once the agent has completed or streamed, we're going to be streaming the results back. So we're going to deconstruct the JSON fragments directly within the API route as well. And then we're going to handle them via the hook so that we can display them on our component called event timeline for the streaming responses. And then finally, the user will be able to see on the page the main results. So now I'm going to show you just very quickly how this is set up in the code. So basically, we have the input value here. It's just like a UI component to which we are passing basically the text. Then we are sending the message. And whenever we are sending this message, we are handling the states directly using hooks. And basically what we have here is we create the text message. So we pass the parts to the API endpoint, and then we are returning them. So what's important is obviously we have the messages. We have the user ID, we have the session ID. And then we're going to basically have all these different actions that we can perform. So we can send the message. So then what's going to happen is we are creating the session directly in the route. So we are creating specific. So as you can see here, we're hitting the endpoint that I showed you. So we have apps, app name, users, user ID, which we are providing, and then the session. Now we're creating a new session. And then we're passing this information to the URL. Then what we have is we are processing the parts. So we have the thoughts as part of the reasoning. We have the function calls. So we're basically like structuring the different parts from the response of the agent so that we can display them differently. And so that's pretty much how this works. And in the agent store, we are basically handling the response. And finally, what you can see here is that we are returning the set of event items from the streaming response. So you can see that basically the event timelines are then rendered on the page. So if I go back to how the agent runs, so this is pretty much, so what's my net worth? As you can see here, it's hitting the run SSE, so the server-side engine, and it's to process the different activities. Okay, what are my different sources of assets? So I think there's a combination of like 401k, and so on. So now you can see it's running, it's adding every single action. So the message that we sent, how much do I have in my 401k? So now it's calling the remote agent that has access to the financial transactions, and it knows that I have 50,000 in this account. Perfect. How many liabilities do I have? So I guess you understand that it's basically sending the parameter, how many liabilities. It's sending this to the remote agent, results. So this is coming from a student loan and credit card. Okay. Perfect. So in this video, I tried to show you as much as I could about what we built as part of the Google challenge. What I learned the most in this challenge was how we can super easily, in 3 lines of code, actually connect to remote agents. So as you can imagine, if you are to build out an army of different agents, you can connect them and really augment the capabilities of your agents without having to rebuild everything from scratch. The second part is around code execution. So one of the major limitations of LLMs is this inaccuracy in coming up and performing calculations, whereas with this built-in code functionality, it's a lot more robust. And as you saw, we created multi-modal agents that could create graphs that you can save as artifacts, meaning that you can then reuse them later on, display them on your front end, and so on. So those are like the 3 learnings, I would say. And then the 4th learning is that you want to create a powerful agent that is with the SSE endpoint, meaning that you're going to stream the server events. And therefore, this is going to give you your user more visibility into how the agent is calling tools, thinking, returning responses, and so on. So not only it reduces the latency and the perceived latency, but it's also very helpful to build up trust, which is one of the major limitations today with agents. So yeah, I think for me it was super exciting to play around with those different functionalities. If you have more thoughts or questions about what we built, obviously all of what I've showed you has been built in under 5 hours. So there are a couple of things that were vibe coded, a bit like on the fly, which could have been improved. But I think it shows you really how you can build some fairly cool agents very fast. If you want to follow me for more AI content like this, don't forget to subscribe to the channel. And otherwise, I will see you very soon for more AI content. Ciao.